that in mind. All right, here's relative velocity problems. Let's do number 2. So let me read it. It says a plane has an airspeed of 80 meters per second and has a heading that points to the east. So the airplane in the air is physically pointing to the east and moving with an airspeed of 80 meters per second. What is the velocity of the plane compared to the ground if the plane is flying in has a velocity, and by the way, I wrote speed there and I should have said velocity more properly, of, and then A, B, C, and D. I worked those, you have to work those different little problems. So let's do it. So let's write down what's given here. So this is number 2. And given you're given, well, first of all, let's draw our east, west, north, south, right? Those are the directions that we're going to use. And the hardest part about this is figuring out what you're given. It says a plane has an airspeed of, so this is the velocity of the plane compared to the air. And it has an airspeed of 80 meters per second. And what direction is to the east? Let's write this in polar coordinates. East is how many degrees? 0. Does that make sense to everybody, that that's what's given? Now, for part A, it says, now this is the velocity of the air. Now, it says the velocity of the air is 30 meters per second to the east. See what I did there? 0 degrees. And then for part B, the velocity of the air is 30 meters per second, but it says to the west for part B. Now, what direction is to the west? You know, it is negative. Yeah. If we were going to do this in rectangular coordinates, we would do negative. In polar coordinates, how would I write this? What is to the left as an angle? Let's call it 180 degrees. Does that make sense? If you wanted to write it in rectangular coordinates, you could have put negative 30 and 0. But that's the same thing in polar coordinates. And then for part C, the velocity of the air is 30 meters per second. At what angle? To the south. What angle is to the south? 270 degrees. Good. Because you know, here's polar coordinates. You want to go rotate around that way. So that would be 270, like that. And then finally, let's look at part D. The velocity of the air is 30 meters per second. But what angle is this? 50 degrees north of west. So here's north, here's west, 50 degrees. So you want to go up 50 degrees from that. Looks something like that. Now, what angle is this from here, though? So, yeah, that would be 130 degrees, 130 degrees. Do you all see that? So if I give you a problem like this, the first thing you want to do is try to express it in polar coordinates. It's usually the easiest way to write it down based on what's given. And you'll see that on the quiz that you're going to take in a few minutes as well. Okay, so what are we trying to find in all of these cases? We want, what is the velocity of the plane compared to the ground? So I'll just write that as the velocity of the plane. Okay, so now let's solve this problem. And, well, what do we know? Well, for all of them, the velocity of the plane is equal to the velocity of the plane compared to the air plus the velocity of the air. Okay, now that should make sense to you. The velocity of the airplane compared to the ground is equal to the velocity that the airplane is moving through the air plus how fast and what direction the air is moving. Okay? And so now let's do part A. So let's take the velocity of the plane. Let's just draw a sketch of it. So this is 80 meters per second. This is the velocity of the plane compared to the air, plus the velocity of the air, but that's in the same direction, and it's just 30. So what's the velocity of the plane compared to the ground? It's just all of this. Do you see how I hook these up head to tail? The velocity of the plane compared to the air, plus the velocity of the air, gives me the velocity of the plane compared to the ground. See, it's got a tailwind. It's actually moving faster than it thinks. So the pilot looks at the airspeed and it says, oh, I'm moving at 80 meters per second. But compared to the ground, you know, he or she is moving at what speed? So the velocity of the plane is equal to 110 meters per second at what angle? 0 degrees. Okay? Does that make sense to everybody, what I did there? This one's really easy. If you draw the picture, it's really easy. Now, if you want to break them up into rectangular coordinates and add them up and use the inverse tangent and Pythagorean theorem, you can. You get the same answer. But if you draw a picture of it, sometimes it's just, oh, it's 110 at 0 degrees. Now, B is really not much more difficult. The velocity of the plane compared to the air is, once again, 80 meters per second. But now, the velocity of the air is 30 meters per second at 180 degrees. So there's 30 meters per second at an angle of 180 degrees. So the answer is, well, when we add vectors, you go from where the first one started to where the second one ended, or the last one ended. So what is that going to be? Yeah, it's going to be 50 meters per second at what angle? So the velocity of the plane is 50 meters per second at 0 degrees. Yes? Does that make sense to everybody? Any questions? Okay. You got it? Okay. Yes?
Why would it be 0 degrees and this supposed to be 180?
Well, the question is, why is it 0 degrees for our answer instead of 180 degrees? The velocity of the air was at 180 degrees. So really, this is like a pilot flying into a headwind. So the pilot thinks the air is moving by the plane at 80 meters per second. But the air is moving backwards at 30 meters per second. So compared to the ground, it's actually only moving 50 meters per second, but in this direction, like this. And this direction to the right or to the east is 0 degrees. Okay, good question. Now, part C, this one's a little bit harder. And so, here we have the velocity of the plane compared to the air, which is still 80. But now, the 30 meter per second velocity of the air goes down like this. It goes south. At 270 degrees, it's due south. So, the direction the plane is actually flying in compared to the ground, well, it starts here, and it goes like that. Now, I want you guys to help me out here with the arithmetic, please. This just makes a right triangle. Now, I'll tell you what, I'll go ahead and solve this more rigorously. We'll go the velocity of the plane compared to the air plus the velocity of the air. See how I'm going to line it up like this? Now let's go ahead and put them in rectangular coordinates. The plane compared to the air, that's 80 meters per second. 0 meters per second in the y direction. Now what's the velocity of the air? 0 meters per second in the x direction. But what is it in the y direction? What? Is it 30? Negative 30. So the velocity of the plane is 80 meters per second in the x direction, negative 30 meters per second in the y direction. Yes? And so now I can just use Pythagorean theorem. Please, somebody get your calculator out and do this for me. The speed is going to be the square root of 80 squared plus 30 squared. Remember, you don't need to put the negative. I'll go ahead and put the meters per second outside the radical. And what do we get? Probably be like 85 or 86. 85.4. Now let's figure out what the angle is. I'll do that up here. We'll take the inverse tangent of the y value. Oh, I'm sorry. Theta equals the inverse tangent of the y value, which is negative 30 over the x value. Now, am I going to need to add 180 degrees to my answer? No, because the x is positive, so I'm on the right side of the xy plane. Your calculator can deal with that. But it is going to give me a negative angle, like negative 20 or something. 20.5? 20.5-ish?
20.6.
Okay. So this is going to be 20 points, negative, right? Negative 20.6 degrees. So let me combine all this together. So the velocity of the plane compared to the ground is going to be 85.4 meters per second at an angle of negative 20.6 degrees. Do you have to add 360 degrees? You don't have to. You can leave it just like that. If you want to, you can. But you don't add 180 degrees to this angle. When would you add 180 degrees? Yeah, if the x component was negative. Even if the y component doesn't matter in terms of when you add 180 or not. It only matters if the x is negative. Okay, so let's do part D. And I'm going to put part D up here because I don't want to use another sheet of paper. So here's part D. So let's do this again. We're going to say the velocity of the plane compared to the air plus the velocity of the air will equal the velocity of the plane. I'm going to write this kind of small so I can fit it in here. So if you need to squint, I'll just zoom in here. So the velocity of the plane compared to the air in polar coordinates would be 80 meters per second at 0 degrees. And I can use sine and cosine and all that, but I'm not going to bother with that. But the velocity of the air, it was given to be, it's 30 meters per second at 130 degrees. To get that into rectangular coordinates, I would go 30 meters per second times the cosine of 130 degrees. And then 30 meters per second times the sine of 130 degrees. Yeah, and that's to get it into rectangular. Now let's go ahead and do those calculations. So the velocity of the plane compared to the air equals, now let's get this in rectangular coordinates. That's just 80 meters per second in the x, 0 in the y, plus the velocity of the air. Well, how fast is the air going in the x direction? What's that? negative 19.3 meters per second. And what about in the y direction? 30 times the sine of 130. It'll be positive. Say it louder. 22.98. Do you agree with that? So now they're in rectangular coordinates, so I can just add them. And then 80 minus 19.3, what is that? That's 70, 60.7? Positive 60.7 meters per second. And we'll draw a sketch here to check all this out. Now what do I have to do? Yes? I can't hear you. Say it louder. Should it be 140? No. Well, did we mess up? Let's see what was given. It said 50 degrees north of west, and I want 50 plus 130 equals 180. So no, this is correct. Right, to get it into polar coordinates. All right, now, let's just do this is equal to the velocity of the plane compared to the air. Now, we got to get it into polar coordinates. And on the quiz, you have to put everything in polar coordinates. So 60.7 squared plus 22.98 squared, and this will be in meters per second. So what do you get for the velocity of the plane? What's that? 64.9. Do you agree with that? So there's my magnitude. Now what's my angle? The y over the x. No, I mean rounding off. You might have little rounding off differences. You don't need to put the units because it'll cancel out. So I can tell already that my answer is going to be in the first quadrant. So what's my angle when I do that? What is it? 20.7. So I can say, all right, the velocity of the plane in polar coordinates is 64.9 meters per second at an angle of 20.7 degrees. Whew, that's a lot of work. Now, one thing I didn't do is I didn't draw a sketch, and I want to draw a sketch to check my work. So let's draw the sketch for part D. This is going to be 80 meters per second. And that's the velocity of the plane compared to the air. But the velocity of the air is at 130 degrees, and it's only it's 30, so it's something like this. So there's our 30 meters per second, and that's close to 130 degrees. So here's my R, and it looks like it's a lot less than 80, and it certainly is. And 20 degrees, does that angle look like it's close to 20 degrees? Yeah, it's pretty close. So when I draw a little sketch, it agrees with my answer. Boom, I'm all done. So let's zoom out as far as we can. Take a look at the whole problem. And here is number 2. It's kind of a lot of work. But notice, A and B are trivial. If you draw the picture, it's almost no work at all. C is a little bit more. D, oh my gosh. And on the, you have to go through all this on the quiz today. Yeah, quiz today. Even Tim has to take it. No, Tim, you don't have to take it. All right. That is all.